to this computer. So let me stop sharing here and go back. And it shows us that we are recording. Okay, so perfect. So what kind of questions did you have for me from that first homework? It was like 19 questions, I believe it was. Were there any of those that you would like to see me go over in a little bit more detail with you?
Number 15.
Number 15, you got it. All right, so we got this page. Yes. Number 15, you said, right?
Yes.
All right. Number 15 says 3x squared plus 5x minus 4. Okay. So first thing I do is when I'm looking at this problem is, do I have a greatest common factor other than one that can come out of all three? And the answer is no. I can't factor a 3 out of all of them, or I can't factor a 5 out of all of them, and I can't factor a 4 or a 2 because that's what the factors. So there's nothing to factor there. So what first thing I'm going to do is I'm going to multiply those two together, and that's going to give me a negative 12. And me understanding when I multiply two numbers together to get a negative, I need a one positive and I need one negative. Okay. And so I always like to list the factors. And we take a look at it and say, okay, I have 1 and 12, I have 2 and 6, and I have 3 and 4. Are there any of those that I could add together, one being positive, one being negative, that would add up to 5? And the answer is no. So I couldn't have positive 1 and negative 12, or I couldn't have negative 12 and positive 1. I couldn't have negative 2 and positive 6, or negative 6 and positive 2. I couldn't have positive 3 and negative 4, and I couldn't have negative 3 and 4. None of those work. None work. Okay, so by us doing that, that means that this won't factor. And so generally the Algebra 1 thing that they do on this is they want you to say that it's something called prime. And prime is not a, meaning in this context, something that you go and watch some movies or TV shows on. It's not an internet site, okay? So that one won't factor all the way down. Did anyone have it factor? I don't think it's going to factor. Okay, so that one's done. You just have to write prime on it. It will not factor, or nope, or or not this time, or anything like that. What else did you see off our problems that we had worked on that you would like to see a little bit more in depth?
16.
16? You got it.
Mm-hmm.
Okay, problem number 16 is x to the third minus 5x squared plus 3x minus 15. Is that right? Looks right. So we have 4 terms. So being we have 4 terms, what I'm going to do is I'm going to look at my first 2 terms, and I'm going to realize I can factor an x squared out of both. And that leaves me x. If I factor x squared out of that, leaves me x. If I factor x squared out of that, leaves me minus 5. Okay? Then I'm going to go to my next 2 terms. This sign here will always come down, so I can factor a 3 out of both of those. So that's going to leave me an x minus 5. If I factor a 3 out of that, I get left x. Factor 3 out of that, I'm left with the minus 5. And then I have these are the same. If they are the same, that means the rest of this will factor. And then this is what I have left over. And then you have to double check. Well, this won't factor any further, and that won't factor any further. So this is my answer, and that's as far as you can go. And of course, you're allowed to have x squared plus 3 and x minus 5 for an answer as well. It's just kind of your choice. Okay. What else do you see, my friends? Ouch. What else did you see on there?
Can we do number 19?
Absolutely. Number 19. Uh, 2x to the third plus 5x squared plus x. And then minus 2. Okay. So we do have 4 terms. So let's take a look and say, is there anything I can factor out of both of those? I can factor an x squared out of that, and that leaves me 2x. If I factor an x squared out of that, it leaves me just 2x. If I factor an x squared out of that, it leaves me plus 5. And then I need to look here and say, okay, well, this sign has to come down, and I could probably factor a 1 out, but then I get to this point here. Now, my friends, is this and this the same thing? And I would say no. So right then and there is as far as you could factor it. So technically this is the answer like that, and you can't go any further. What else do you see from me, my friends? And then they say something, they say, hey, maybe we should factor using synthetic division. Ooh. Ooh. Factor using synthetic division. What does that even mean, my friends? My accelerated algebra 2, when you had me in class, I know we talked about it, but I'm not sure what you talked about in your algebra 2 class.
So synthetic division is just a way to quickly divide it. If you have one solution, one or more roots, you can factor it very quickly.
So let's take a look to see if we can indeed factor it. I would say right now it's not going to work. So if we jumped onto the synthetic division part, what we're going to do is I'm going to look at all of the factors of this over all the factors of this. Okay, so let's take that negative 2. I know plus or minus 1 and plus or minus 2 work. And then for the 2, I know that plus or minus 1 works and plus or minus 2. So if we were to list everything that could happen, we could synthetically divide by, is we have 1 over 1. So we could try synthetically dividing by that. Go to this one, that's plus or minus 2. So we could try that one. And then, so that took care of everything over that. Then I can go plus or minus half. And then I have plus or minus 2 over 2. Well, what's 2 over 2? Is this one the same thing as plus or minus 1? And the answer is yes. So we already have that right there. So we can double check to see if synthetic division works. It is possible it doesn't. I think we've shown that it's not factoring, but let's use synthetic division. Okay, so I'm going to start with just 1, positive 1, and I'm going to look at each of these lead coefficients. So I have a 2, I have a 5, I have a 1, and I have a negative 2. So if I bring this straight down, 2 times 1 is 2, add here, that gives me 7. 7 times 1 is 7, add straight down, that gives me 8. 8 times 1 gives me 8. If I add those together, I get negative 6. Okay, so what that tells me is if I had a graph, that 1 comma negative 6 would be a point on the graph. I'm looking to see where that can become a 0. That very last term, that negative 6 becomes a 0. So it didn't work with positive 1. Okay. So I'm going to come down a little bit and let's try negative 1. And if synthetic division is something you haven't seen before, let me know. It's not a real tough thing to do once you see the routine of it. So I'm going to bring the 2 straight down. 2 times -1 is -2. Add straight down. That gives me a 3. 3 times -1 is -3. Come straight down. That gives me a -2. 2 times -1 is +2. Add straight down. That gives me a 0. So that means 1, 0 is an answer. So in order for me to get that, if x is equal to -1, that means the binomial x plus 1 is a factor. Okay? That means x plus 1 is a factor. Okay, so if I go a little bit further, knowing that, I know that x plus 1 is a factor. Originally, when I looked at this first problem right here, from above, this would have been 2x to the third plus 5x squared plus 11x minus 2. But then I get this part here, so I'm going to be 1 degree less. Well, this was to the third, so this could be to the second. So it's going to factor down to 2x squared plus 3x minus 2. Okay? Now, I don't know if that's going to factor any further. I know so far, if I were to take this and I were to multiply it out, so I multiplied x times those 3 terms, and then 1 times those 3 terms, combine my like terms, I would get my original 2x to the third plus 5x squared plus 11x minus 2. Okay? But I don't know if it's going to factor any further. Okay, so let's think about just this. Would it factor again? Okay, now we already know +1 doesn't work, but -1 could happen a second time. So I'm going to use synthetic division on this part here. Okay, so I'm going to divide by 2, 3, and -2, and I'm going to see if -1 works a second time. So I'm going to bring the 2 straight down. 2 times -1 is -2. That's going to give me 1. 1 times -1 is -1, so that gives me -3. So that means it's not going to work for a factor. But then I can say, okay, I had other iterations. I've gone through as much as I can with a +1. So now let's try the +2 to see if it works. And I'm just going to see if the +2 works here. I don't need to see if it works anywhere else. Okay, so I have 2 divided into 2, 3, -2. Bring this straight down. That's 2. 2 times 2 is 4. That gives me 7. 7 times 2 is 14. Bring that straight down. That gives me 12. Well, +2 didn't work. So let's try the -2 on the same thing. So I get 2, 3, -2. Bring that straight down. That gives me a 2. 2 times 2, that's 4. Bring that straight down. That gives me -1. -1 times that is 2. Add those, I get a 0. Oh, so this worked, which this is the same as this binomial. So if I had x equals -2, if I added 2 to both sides. So right now I know that I have x plus 1 that worked for my original. I also know that x plus 2 works, but then I have to check to see what this would be. Well, originally when I was dividing, that was x to the third, but now that's x to the second. Okay, and then that's x to the first. So that means that 2x minus 1, so that whole thing is my factored thing. That's pretty deep. And I think that some of you might be like, wait a minute, how did you and why did you? And that's kind of a little bit different thought process. So that problem truly did factor out, even though it didn't work by factor by grouping. And but is there anybody here who has not seen synthetic division before? Is it new to anybody?
I've seen it. I'm just really, really, really bad at it.
Okay, so we can take some time and talk about it and try and make it work a little bit better, okay? So was there another one of the problems that didn't factor all the way out by grouping? I don't know how number 18 came out. Number 18 might be another one. Can I do number 18? Is that cool? All right. So let's try number 18. Okay, so number 18 says I have x to the third minus 6x squared. And then I have plus 11x and minus 6. So our factor by grouping probably will not work. So let's not jump on that right away. So what I'm going to do is this. Is everybody okay that I put that 1 out in front? So what I want to do is I want to take all the factors of 6 over all the factors of 1. So the factors of 6 are this over all the factors of 1. So here's the nice thing. We're only synthetically dividing by whole numbers. Okay, the positive negative 1, the positive negative 2, the positive negative 3, and the positive negative 6. Okay, is there any questions up to that point? We say, is that okay so far?
Yep.
Okay. All right. So what I'm going to do is I am going to take, being that I go third, second, first, none, I'm going to take my lead coefficients of each of these, bring the sign along, and I'm going to divide by those. Okay. So I have inside my upside down radical this. Is that okay? Then we have to start. Where should we start? Okay, realizing that my answer that'll come down here, down below, will be x squared. Okay, we don't have that yet. So let's see if we can start doing it. So we have to start someplace. So let's start with positive 1. Okay, let's see if that works. Bring that straight down. 1. 1 times 1 is 1. That's going to give me negative 5. Negative 5 times that is negative 5. Add straight down, that gives me a 6. 6 times 1 is 6. Add straight down, I get a 0. It worked. Okay, which means because this original one up here was x to the third, that means that this is x squared minus 5x plus 6. Okay, this means x is equal to 1, so the binomial that it refers to is x minus 1. So far I know that x minus 1 times x squared minus 5x plus 6 works just fine. Now, we don't necessarily have to synthetically divide it again. We can look right here and say, hey, can we factor this normal? And I think so. I think x minus 1 is fine, but then I know that I have x, and I know I have negative 3 and negative 2. So if I were to FOIL this just together, I get x times x is x squared. Outside is negative 2x. Inside is negative 3x. That gives me negative 5x. Negative 3 times negative 2 is positive 6. So this problem factored completely out by using synthetic division until we got it down to x squared. Once it got down to x squared, we can go down and say, hey, can we factor it? If we can't factor it, we might have to use synthetic division a little bit more. Okay, a little bit different thought process on some of those problems, but I think we can definitely work through any hiccups and fill any gaps you might have and make us all better, not feel bad if we didn't get it right away. Okay. We say, do you feel okay about that?
Yeah, just looking over the steps made me remember it again.
Cool. Does everyone else feel comfortable with this? Is anybody that I don't see? I see Jacob nodding, but I don't see anybody else or hear anybody else. And again, it always becomes your choice if you want your video on or off. You don't have to have it on. You're not offending me if it's not on. You're not offending me if it's off. And I get it. It's not a big deal. And I'm sorry for the teachers like, I have to see you, darn it. And you're like, whatever. So silly stuff. What else do we got? What other problems from last night do you want to take a look at? Do we feel comfortable with it? We're good? Did y'all do it? All right. I am, being you're all here, I am giving you all the first homework. Typically how I will do homeworks algebra review number 1. Typically how I check off homework, my friends, when we are in class, like when you're sitting actually in my classroom, is I'll just ask you to have it out on your desk. I'll come by and just spot check it. I will not pick it up. I'm not grading it. It's your practice. And if your practice, you did things incorrectly, then make sure we're asking questions in class to make sure you can get it correct. But even if you get things wrong, that doesn't mean I'm docking points. I'm just giving you points for the practice, okay? All right, so let me stop this share for a sec. Let's come back to this share. And let's just take a look at what this evening would hold them true. So there's 2 homeworks that are there. Only one of them will be due on Tuesday and Wednesday, correct? Because it has a due date on it. This one will be due on Thursday and Friday, but I don't have that done yet. So, and I'm sorry, this is going to upset some of you. I'm sorry about that. I probably don't have a homework planned for this coming weekend for you. And I know that you're probably kicking your dog right now and throwing stuff at the wall and stuff like that, but I'm really sorry. I didn't mean to not make that, but I do have a quiz that we'll do on Thursday or Friday, depending upon which cohort you're in. But let's take a look at what this homework is and just see how different it might be from what we have already explored. If it would load. All right. Oh, there are equal signs, aren't there? Oh, solve for y. All right, so let's do me a favor, my friends. Take a look at those first 9 problems. Take a look at those first 9 problems. Are there any of those 9 problems that you would like to see worked out a little bit more? Anybody see any you would like me to work out a little bit further?
Number 5.
Number 5, okay. Is there anything else from those first 9 you'd like to see me work out?
Number 7.
Got it. Anything else from those first 9? Okay, let me scroll down. Is there anything from those 6 problems you'd like to see worked out a little bit differently?
What are the bottom 3?
Bottom 3? How about I do all 3 of those?
Perfect.
All right. And then moving up, whoop, these are, I'm sorry, they're a little blurry. If you shake your head real fast, maybe it makes it less. I don't know. Is there anything from those you would like to see worked out?
Any one of the 6 of them.
Okay. So let's see. I'm going to jump on. How about I do number 21, and I'm going to show you how I'm going to do that. And I think y'all are going to like what I'm going to show you on that in a sec. So let's go back. I'm going to stop sharing here. Let me work those problems. If you'd like, please write down what you see and we'll cover those, okay? So problem number 5. That's it. So problem number 5 says 3x minus 4y equals 12. And they want us to solve for the y value. So that means I want to get y by itself. So what I'm going to do is I'm going to subtract 3x from both sides. Those cancel. And it is a positive 12, so I'm going to make it as plus 12. And then I'm going to divide everything by negative 4. Those cancel, so I get y equals negative over negative is positive. Positive over negative is negative. And so that's how you would do problem number 5. Okay. Then let's take a look at number 7. Can I move on? If you were saying, don't move on, I didn't hear you, so I apologize. So I have x and then 5x minus 2. And then I have x plus 7. And it's equal to 0. Now, being it's equal to 0, that means I can take each part and set it equal to 0. And solve. So this one is solved. This one becomes add 2, divide by 5. And then this one subtract 7. So the boxed in highlighted answers are the answers for that problem. And the reason why we can just set each part equal to 0 is because the whole thing was equal to 0. It was equal to a number, there was something else we'd have to do, but I don't see any that are like that right off the bat. And then let's talk about 13, 14, and 15. You ready? Oops. It's better when I have it as a pen. Number 13 says x minus 2 and x plus 3. And we have an inequality sign. Okay, so first thing we're going to do is, because it's equal to 0, I know that this is going to give me x equals 2. This is going to give me x equals negative 3. So on a number line, I'm going to have negative 3 on the left and 2 on the right. Okay, so we want to know where the values are greater than, we want to know where they're greater than 0. Okay, so there's a shortcut on these problems, my friend. The answer is either going to be like this, or it's going to be like this. It's one or the other. Okay, and let me explain what that means here in a sec. All right, so something is going to take place in between these two. So what is a value that is in between negative 3 and 2? That's a nice whole number. We can pick negative 2, we can pick negative 1, we can pick 0, we can pick 1. What would you like me to pick?
1.
1? Okay. All right. So if I pick the 1, and you all feel comfortable that 1 fits in between these two, agreed? So if I take that 1 and I plug it in, I'm going to get 1 minus 2, which is negative 1. And I'm going to multiply that times 1 plus 3, which is equal to 4. So negative 1 times 4 is negative 4. Is negative 4 greater than 0 or less than 0? What do you think? Is negative 4 greater than 0 or less than 0?
Less than 0.
Less than 0. So that means this whole region in between these two, right in between here, no matter what value I plug in, decimals, fractions, anything that falls within there, that would mean that we have negative values. So that automatically means over here is going to be positive and over here is going to be positive. So if I continue to go this way forever, I get to negative infinity. If I continue to go this way forever, I get to positive infinity. So we want to list where our value is greater than 0, which is positive, as interval notation. So what I'm going to do is I'm going to say from negative infinity to negative 3, round bracket, because I don't have an equal sign. There's not an equal sign here. It's just one inequality. And then from 2 to infinity. Those regions, if I plug any numbers in to the left of negative 3 and any numbers to the right of 2 into our equation, we're going to come up with a positive answer. Is that okay? So I'm going to hit on number 14. Number 14 is done very similar. Okay, can I move on?
Yeah.
Okay, thank you. Number 14 says 3x plus 1. And it also says 2 minus x. And we want values that are less than 0. So less than 0 means negative. Okay, so I'm going to solve each of these. So I'll go 3x plus 1 equals 0. So 3x equals -1, x equals -1/3. And then this one, if I set that equal to 0, so I'm going to get 2 is equal to x, so x equals 2. So I'm going to draw myself a number line and draw my -1/3 here and draw 2 over here. Okay, so my sign line will either be plus minus plus or minus plus minus. Okay, so I need to figure out. So could I pick like a number here? Like I know I got 0, I got 1 that fit in there. So I can pick one of those and plug it into my original to see if it gives me a true statement or a false statement. Okay, so let's pick 0, plug it in. So 3 times 0 is 0, 0 plus 1 is 1. And then if I plug 0 in here, I get 2 minus 0, which is 2. 1 times 2 is equal to positive 2. So that means the region here in between these, this region in between these, is going to be positive. That means out here is negative and out here is negative. Okay, so I want values less than 0. So remember, this is going to continue to negative infinity. This is going to continue to positive infinity. So we're going to go from negative infinity to -1/3. It's a soft bracket, a round bracket, because I don't have an equal sign. And then from 2 to infinity. That is my solution set for my answer. Oh, my computer turned off. Dang it. Can't have anything nice. And so number 15 is going to be done the same way. Now, the only difference on number 15 is the inequality sign also has an equal sign. So that means we're going to have hard brackets on my numbers. The infinities still have the soft brackets or the parentheses, but we're going to have hard square brackets on the numbers because there's an equal sign. So number 15 does this. 2x plus 1. And x minus 5. And we want values that are less than or equal to 0. So I'm going to take that, set it equal to 0. So 2x plus 1 equals 0. Subtract 1. Divide by 2. And then this one, x minus 5 equals 0. So x equals 5. So let's put that on a number line. So I get -½ here. I get 5 here. Okay. So again, we need to pick a value. So, you know, I have 0 here, and I got 1, I got 2, I got 3, I got 4, so on and so forth. So if we pick there and it's negative, that means it's less than 0. So this is less than or equal to 0. So that would be, we're looking for negative, because negative numbers are less than 0. So I'm going to pick any one of those numbers. I'll pick the 0, plug it in. 2 times 0 is 0. 0 plus 1, that gives me a 1. 0 minus 5 gives me -5. If I multiply 1 and -5 together, I get -5, so that's negative. So that means this whole region here is going to be negative. Out here is going to be positive. Out here is going to be positive. So I want values that are negative. Okay, because I have the equal sign, I want hard brackets. So if I pick any numbers, including -½ and 5, and I plug them in, that's going to give me a true statement on my original. But that's the interval notation to that problem. Okay. Now, number 15. Number 15, I'm going to introduce you to my little friend. My little friend is known as Desmos. Okay. Okay, so the nice thing is Desmos is a free app. You can always load it on your phone. I also have Chromebooks in the class, so you can always use one of my Chromebooks and go to desmos.com and it becomes a graphing calculator. So problem number 21, we have 3.6 raised to the 2x power, and I have 47.2. And what we want to do is we want to solve it. So I'm going to tell number 21. Let me show you 21 real quick, just so you can see what I'm going to be plugging in. So 21, my left side is 3.6 raised to the 2x power, and my right side is 47.2. Agreed? This is something that your Algebra 2 teachers, if they were good teachers, should have shown you. I'm not a good Algebra 2 teacher, so I didn't show my kids. Okay, so I'm going to set my left side, which was 3.6 raised to the 2x power, and it gives me a graph. And then I'm going to graph my right side. I'm going to set them both equal to y equals 47.2. Okay, now I can't really see 47.2 because 47.2, I have to zoom out a little bit to see it. And see how I have that blue line in there? And let me change this to projector mode so it's nice and dark. You see how the red and the blues intersect each other? You're going to take your cursor, you're going to hover right above that, and the x value is all you're worried about. So my answer to problem number 21 is 1.505. That's the answer. Okay, it says round to the nearest hundredth, so we could do it to 2 decimals, so we go 1.51. I'm not, that person is going to be like, oh no, you gave it to me the thousandth and I asked for the hundredth, so I'm taking points off. I'm not that guy. So that's a really unique way of doing that. And I will always allow you to use Desmos. And the reason I'm not going to the graphing calculator on this is one, not everyone has it, but two, Desmos becomes a real easy thing. So if you ever want to add Desmos to your phone, go for it. Just go into the App Store, type in Desmos, and it'll say something like free graphing calculator. Add that app, and you'd be able to use your phone with Desmos. The nice thing about your phone is it is touch screen, which is great. But just go with that. So, my friends, that is all I have for you. So what I would like you to do for either tomorrow or for Wednesday, depending upon which cohort you're in. And here's the thing. This is how I always deal with my homework, my friends. Okay. In business calculus, this is how I deal with it. This is the pages that you have. You do not need to print those off. You're more than welcome to write on a separate sheet of paper. It doesn't have to be an exclusive piece of paper. I'd say probably don't put this on your same sheet of paper you wrote your German homework on, but you know, it doesn't have to be a clean sheet. It could be always a one side, half side little sheet, napkin or something. But do the problem. Do me a favor, my friends. If I ever give you a homework assignment and you are over a half hour worth of time working it, then stop. If you could tell me in class, you know what, I gave it 30-minute, honest 30-minute. I'm not talking 30-minute where you like had it sitting on your desk for 4 hours and you didn't do anything. I'm not talking about that. If you gave me an honest 30 minutes and didn't get done with a homework assignment, that always counts as a homework assignment's done. Okay. And I'm not saying that because I'm trying to be an easy teacher. I'm saying that I just don't want to overwhelm you. Believe me, I understand sometimes in math, you get to something where you start looking at it at a problem and you're like, oh my gosh, I am totally blanking. Well, try it. If it goes beyond a half hour where you've tried some of the problems and you're like, I'm still not getting it, don't lose sleep over it, but just come in and do it. So that's all I have for you, my friends. I will see half of you tomorrow. I'll see the other half on Wednesday. Have a great day, my friends. Take care of one another.
Thank you, Mr. Stirrup.
Bye, everybody.
Thank you.
Thank you.
Bye.